All right, so we're getting through the last section, factoring. This is huge. Big stuff in Algebra 2. Factor by grouping. This is one of my least favorite because I feel like it really has to work in order to work. You'll see what I mean in a little bit. But I suppose I see it, again, as kind of brain candy. I'm exposing you to something. Give it a try. Try it. So I'm going to group these guys and these guys. And I see that they have an x squared in common. And when I pull out the x squared, I get an x plus 1. And I can see this as a 1 times an x plus 1. And then what you have to see here is suppose I had this is kind of like saying an x squared times a u plus a 1 times a u. Can you see that? And then therefore I can pull the u out. So I'm undistributing the u, right? U times x squared would be x squared u. U times 1 would be 1u. But what was really my u? It was this x plus 1. So there's my factor. So essentially, once I pulled the common factor out of this group, and once I pulled the common factor out of this group, now there was another common factor that I could pull out. So let's try that again. I'm going to take this group, who can come out, the x squared, and I get an x plus 5. And then who can come out here, a negative 9, and I get an x plus 5. So here's the thing, you know you did it right if you get a common factor. So now I can pull that common factor out. And what am I left with? An x squared minus 9. Oh, and if we're really sharp, we recognize that x squared minus 9 can become an x plus 3, x minus 3. Now we haven't gotten to solving, but I'm just going to throw this out here now. If I set that equal to 0, I could readily see that my x-intercepts are a negative 5, a negative 3, and a positive 3. So I'm going to go through that shortly. But anyway, that's what makes this beautiful if you're into math. So here's my group, who can come out, x squared times a 3x minus 1. And who can come out here? A 3 times a 3x minus 1. And then this common factor can come out front. And then this is what I'm left with. So there's my two factors. Here's my group. Here's my group. 4x squared gives me an x plus 2. And I'm going to pull out a 9, negative 9. And get an x plus 2. This can come out front. And then I get a 4x squared minus 9. And if you're sharp, you can see that this becomes an x plus 2. And these are perfect squares. 2x plus 3, 2x minus 3. Factor by grouping. Give it a shot. But like I said, I mean, how coincidental does it have to be that this works? I don't know. Sort of fun to try it and see it happen. How about quadratic form? So you'll like this, because this is familiar territory, kind of like, So this fourth looks yucky, but hey, let's remember what if we had x squared minus 25? Well, that would just be x plus 5, x minus 5. So if this is an x to the fourth, it just becomes an x squared plus 5 times an x squared minus 5. That's all, right? X times x is x squared times x squared is x to the fourth. I'd get a minus 5x squared. I'd get a plus 5x squared. They'd cancel. Minus 25. So when you see a fourth, just pretend it's a squared. How about x to the fourth plus 7x squared plus 6? Well, you guys would know how to unfoil that, except it's just an x squared and an x squared. Factors of 6 that add to 7, pretty simple. Leading coefficient other than 1 causes us to think about it, although we know it has to be a 3 and a 1 to make a 3x squared. Now I have to find factors of 24 that when I throw them in there and I outer and I inner, I get a negative 1. How about 8 and 3? Yes, because if I put 8 here and 3 here, my outer term will be a 9. My inner term will be an 8. That'll certainly somehow combine to be 1. And if I want a negative 1, my 9, my outer term has to be negative, and my inner term has to be positive, and that's how I'll get a negative 24. This is looking a little messy. 3x squared plus 8 times x squared minus 3. What do you want to do here? I want to see if I can find a common factor. Who do you think goes into 15, 72, and 108? And actually, this little x here, x in everybody is also a indication that we might have a common factor. I think it's 3. So I'm going to get a 5x to the 4th minus, I have to do this with calculator right now, minus a 24x squared minus 36. And then I still have my 3x. And again, pretend this is just a squared, except it is a 4th, so those are going to be x squared terms. And since this is a 5, I have to have a 5 and a 1. There's no other factors, thank goodness. Otherwise, we'd have a truckload of trial and error. And 36, I need to put two numbers here that multiply to be 36, and then my outer and my inner somehow combine to be 24. So I don't know, what is that, 12 and 3? If I put a 12 here and a 3 here, 12 times, no, that's not going to work. A 9 and a 4. If I put a 9 times 5 is 45, no, 9. 9 times 4, 20. No, what other factors are there? 12 and 3? 12 and 3. 12 and 3, 9 and 4. Shoot. I can't come up with that off the top of my head right now. And I don't want to prolong this video anymore. Am I missing one? 36 and 1. That doesn't seem right. 36 and 1. If I put a 4 here and a 9 there, 4 times 5 is 20, and 9 does not give me 24. If I put a 3 here and a 12 there, 3 times 5 is 15, and 12 do not give me 24. If I put a 12 there, a 60 and a 3, I'm missing something. Well, I'm going to leave it like that for now. The key here is that sometimes you can pull out a number. I'll get back to you on that one. We've got to move on to solving. Maybe I'll solve this one in the end.